The next set of standard techniques are the vision-based one, and as mentioned to you guys, this is the most advanced technique that we have, and it's upcoming, and the OEMs are adopting these techniques today and implementing it. So some of the basic methods that we use are pupil detection. Here in the leftmost corner, we can see the picture of the eye. The center of the eye is where we have the pupil center. And this portion over here, which is the outer optical portion of the eye called the cornea, we have sensors that basically can detect the reflection from the pupil and the cornea. They call corneal reflection. Once we get to find the vector that connects the pupil center and the cornea, it's easy for us to understand where the eye is looking at. Now, I don't know if everywhere it's like really small, but the thing is that that is the relative vector between the pupil center and the cornea. And once we get this information from the driver, down you can see how we can convert this two-dimensional input into a 3D eye model and develop this particular vector here, is the gaze vector, to detect the gaze direction and say, hey, where the driver is looking at. It's a very intuitive technique that we have today that requires a whole bunch of sensors from IR illuminators to infrared cameras that do the job today. It's very interesting, and this allows us to literally tell where the driver is looking at. Now, once we get this particular thing sorted out, you can see on the right-hand side here, with reference to the center of the steering wheel and the detected eye gaze movement from the camera and the other sensors, we can simply plot all these informations, and using a lot of math tools, we can simply tell the driver is looking on the road or off the road. It's a very interesting technique, and it's more being used today. The next one here is the face and landmark detection. So this is another important thing that we need to detect. And as you can see on the right bottom corner, there's a whole bunch of points in the face that the image processor can detect. For example, the center of the eye, the corner of the eye, where your nose is located, relevant and like relative to your eye center, your mouth movement, and a whole bunch of other information as well. So all these things are essential to we were talking about detecting all the landmarks of the face. The third one here is the head position and orientation detection. Now this one is mainly achieved through the image processing sensors, the camera mainly, that can detect the head position using these following parameters over here. We can actually measure the yaw angle, the roll angle, the pitch angle of the head movement today with all cameras and advanced techniques we have. The moment we are able to get these three parameters, we essentially know that the driver's head position is either supporting the driver to gaze on the road path, or it's off the road looking at other areas in the around the windshield, or seeing the windows around the driver or the front passenger. So this is another key factor that we detect today to understand where the head position is. And it's a very interesting area as well, because there has a lot of techniques that recently we have developed. The last one is the eye measurement, which is the essential component that can tell whether the driver is drowsy or not. So the eye measurement is all about whether the eye is closed or open, or a percentage of how much the eye is open. So those metrics are measured using primarily the cameras that can provide the percentage of eye openness and how long has it been closed, and etc. So those are measured by the cameras. So the first three are mainly used for the distraction behavior understanding. The last one is primarily with the other These are the most popular ones we use today, and we have a lot of research going on and adopting this technology in the product line itself. Okay, the sensors part on the left hand side, we can see a whole bunch of variants of camera that can see the driver. As I mentioned earlier, the cameras are primarily used for measuring the eyes, the face, and landmark detections. We also use them to find out the reflection vector for the corneal and the pupil, and all those steps are being done by cameras essentially, and they are located either on the steering wheel or they're located somewhere behind the rear view mirror, above the rear view mirror. In the middle, we have these biometric sensors that can read the driver's heart rate, the ambient temperature, and also it can sense the temperature around the driver's facial and other areas. So basically all these other information that can gather from the driver. There are more to it, but I've just shown the steering wheel here. But essentially, all these biometric informations can be gathered from the steering wheel or from the seat itself. Today's seats, they come up with EEG sensors that can detect more details about the driver, and also some of them can read brain activities. On the right hand side here, we have the infrared illuminators. This is a very key sensor that helps us in creating the zones for the cameras to take the right pictures. The IR illuminator, it's and do multiple more processing on them. So they play a key role in making sure that they highlight the essential facial landmarks and area zones where the camera needs to focus on and take the pictures with high accuracy. These are the main supporting system behind the image with high accuracy and detailed processing. I left out the steering wheel sensors, but we all know that those sensors have been there for a long time, and they are primarily focused on getting the steering wheel angle and other. For the state-of-the-art technology, I picked up a few OEMs, three of the OEMs. The first one here I have is the Cadillac Supercruise with seeing machine technique. It's the most advanced technique we have today, which has the driver being monitored by a small IR camera right behind the steering wheel. And this light bar over here contains infrared like bar lights that can project and provide support for the camera to take essential pictures. So Super Cruise, in a sense, is an L2, L3 level automated vehicle that technology we have today that can completely drive the vehicle on the highways mainly. What it does is that it essentially monitors the driver continuously through this camera and the IR sensors. If the driver is not looking on the road continuously for a certain time, it immediately tries to hand over the driver the control. It essentially alerts the driver at the beginning. If the driver the control, it has something called a the side of the road and it parks it over there. This is a very interesting technology that we have in Cadillac today that can detect the driver and provide necessary warnings. So the warnings come through audio visual alerts and also vibrations in the seat, driver seat itself. That helps us to realize that the driver is distracted or maybe drowsy. So the next one I have here is from Mercedes-Benz. They have this attention assist system. It's their way of monitoring the driver. It's very interesting how Mercedes has developed this thing over years. It's a very complex model, as I discussed at the beginning. So Mercedes has a whole bunch of sensors that you can see on the left corner of the vehicle. We have the steering wheel sensor and we have the wheel angle sensors that can provide us a whole bunch of information about whether or not the vehicle is on the lane or in different positions, whether the driver steering behavior shows there's anything that the driver is distracted. So you can see in the top left here that there are systems that can read all the information about the steering wheel angle and provide us certain data. And here we can see that we can check out whether the driver is within the lane or off the lane. And Mercedes has interesting sensors that can tell whether or not you are playing with the infotainment system or not. Now that's another interesting thing. They do detect these things when they find out that driver is possibly distracted. Have detection mechanism to see the road has potholes or any other means that could actually kind of create vibrations in the vehicle movement. So Mercedes has this all sensing ability to create a complex model to figure out whether the driver is distracted or not. And if based on all these information, if the control system thinks the driver is drowsy, you can see simply here that in the dashboard it shows the driver needs a break or something. A lot of OEMs, including Nissan, Subaru, Ford, all of them, they have a very similar technique of showing this thing in the dashboard of the driver, saying that the driver is drowsy and needs a break. The last one I wanted to show here is the EyeSight Technology in collaboration with Seat and BMW. They have the camera right above the rear view mirror right here, you can see. This is from Jabil and EyeSight Technology. This is another interesting technology that we have today that can detect actually precise movement of the head. For example, the yaw angle, the roll angle, the pitch angle. It can also show us the eye openness percentage, the blink rate per minute, and as I talked about, the gaze direction of the driver. EyeSight technology is also venturing into and being adopted by so many other OEMs as well today. I'll show some recent advancement of what they are up to as well. So this is being used in right now in BMW to find out whether a driver is distracted and alert. So for the recent advancement, Toyota's concept I, so this is very, very interesting and intuitive that the sensors over here and the complex model that they have developed can literally read drivers' emotions. That's quite far-fetched. And based on all these information, they can suggest alternate routes for the driver, or it can also offer to take control in low visibility conditions. Now that's mainly to reduce the stress level of the driver. And there are sensors that Toyota has today that can indirectly estimate the stress level of the driver. Now that is another interesting thing, how they do it. But all these are right now in concept only and yet to be rolled out into the OEM models. Next one I have here is, yeah, so this is actually the panel that shows some of the sensors. It's not quite visible what and what not they're sensing, but essentially we kind of aim to sense all the parameters we talked about. The vision methods of checking for the pupil detection, it's all about the eye measurement, the head movement, and all those things. So these are some of the recent ones we are currently looking at. The other one I talked about is the EyeSight technology. The latest trends that we have from this particular technique that we have is EyeSight technology can literally detect who the driver is and adjust and personalize the seats for them. It can adjust your mirrors, the heating and cooling temperature, and a few other settings within the in-vehicle that the driver. It's quite interesting because the technology of the driver, and as and when the driver takes over, this technology can make the settings personalized and comfort the driver itself. Also, they are primarily focused on reading all these other interesting new data like angle of the vision, the blink rates, and some of these techniques that they use are proven to be more accurate than what we have in the other OEM product lines today. So in essence, this can detect and personalize features within the driver in vehicle. The next one is the suggestion of the areas of interest based off of driver data analytics. So this is very interesting that it detects essentially the most common spots the driver visits and creates a analytics and shows. You can see here that it literally shows a bunch of options for the driver. For example, here we have the sports club, we have the car wash, we have a place where we can buy stuffs. So these are some of the interests that suggest by the system itself based off of the analytics it actually kind of extracted over time from the driver. Now these are good advancement and definitely they will be adopted by the OEMs in the future. And that's very interesting for anybody who is interested in entering the automotive segment. The last one here is what I want to talk about, the career paths and opportunities. So if you're looking into getting into designing these driver state monitoring based techniques for all of us to work on computer vision algorithm developments, eye based detections and head orientation position. And as a whole, we have so many computer vision problems to solve. The second one here is the embedded system controls integration. I have worked as an integration specialist for a few years now, and I've seen there's a lot of challenges we have when it comes to integrating an existing solution. There are so many vendors today, so many automotive suppliers have great techniques, but when you want to integrate them into the OEM vehicle, we have so many different challenges that comes in. And this actually kind of gives another functional area where you can look into and improve upon and go ahead with this embedded system controls integration based roles. And the last one is the sensor optimization. Since we have so many number of sensors, there's a way of optimizing them by creating mathematical models and using other optimization techniques. So these are the functional areas I foresee in the future that the driver state monitoring system will need. Here I've just added like a few of the companies and suppliers that have these technology today and are being adopted and used by OEMs. Some of the names are must be familiar, but there's a lot of new players in the market as well. I just added only a few of them right here. Okay, with that, I conclude my presentation and pass it back to the host.